Okay, so this is our last way to solve for x in parabolas. Okay, we've learned factoring. We also looked at completing the square, and we have the quadratic formula. Okay, so you have seen this before. I know you have in Algebra 1. You do not need to memorize the formula, although some of you already have it memorized because you just sang me the wonderful song. But I will give you the formula on the test. Okay, we just have to know how to use it properly and put it in the calculator property, which tends to be where kids make a mistake, is they put something wrong in the calculator. So where do A, B, and C come from? Where are we getting these numbers?
The equation.
What do you mean the equation?
The x squared minus x plus or minus number equals.
Yeah. Yep. So we've got this, we've got A, B, and C. Those are the three numbers we're going to be putting in there. Okay. Why do we use the quadratic formula? Well, I actually just talked about that. These are the x-intercepts of the parabola. Okay, and we can, if something isn't factorable or it's really not suited for completing the square, we can always use the quadratic formula. Sorry, if it's not good for factoring or completing the square. This one always works. Okay, the discriminant. The discriminant is what is underneath the root. So it's b squared minus 4ac. Now, the discriminant, whatever number you get for that part of it, will tell you what kind of roots that you have. And we're going to go through examples of that. Okay, so let's look at what the homework problems are going to look like and also what the test questions are going to look like. All right, so you're going to have 3 things to answer on all of these problems. First, we're going to find the discriminant, which I told you is b squared minus 4ac. Okay, so b squared, and every time you put numbers in, please put parentheses around them so that you get them correct when you throw them in your calculator. It just tends to work a lot better. Minus 4ac. So if you put exactly what you have up here into your calculator, we all should get the same answer. Can a couple of you do that for me? What do we get? 1? Okay, so let's think about that. When we get down here, and we've got plus or minus the square root of whatever we get here goes here. Would you agree?
Yes.
In the quadratic formula, b squared minus 4ac is what's underneath the root. Okay, so our 1 is going to go there. We'll come back to b in a second. We've got negative b, which turns out to be positive 7. And then 2a. So let's think about that. If we get a number like 1, what happens right here? Are we going to get an irrational answer? No, how come? Yeah, you can square root 1, and there's not a root there anymore. The square root of 1 is 1, so we're not going to get an irrational number with a really long unrepeating decimal. Okay, so if we get a number that's a perfect square, we're going to have 2 rational roots. Okay, so let's find those 2 rational roots. If we're looking here, we can simplify this to be 2 plus or minus 1 over negative 6. Now there's 2 answers here. We want to find both of them. Okay, so one of the answers we're going to add the numerator, and the other one we're going to subtract the numerator. So when we add the numerator and divide by negative 6, what do we get? 8 over negative 6 is negative 1 and 1/3. Okay, what if we subtract on the top? Negative 1. Okay, so there's your 2 answers. which matches letter B, says we should get 2 rational answers. We did. Okay. All right. Another one. What do we have to do to our equation? Yeah. Yep, we got to move this over. So we've got negative 8x squared. Okay, so find the discriminant. Do the same thing. B squared minus 4ac. B squared minus 4ac. What do we get? Okay, so let's think about that. If we have our quadratic formula down here, we just found this number that goes under the root. Can we square root that without getting a decimal?
No.
No. Okay, so are we going to get rational roots? No, we're going to get 2 irrational roots. All right, so let's finish out the quadratic formula. We got negative b in the front over 2a, and then we're going to simplify. So we've got negative 4. Can we break down 176 at all? So we can divide it by 2. What are the prime factors of that? Like that. Looks good to me. Okay, and then we got negative 16 down here, right? So let's simplify our radical. We're looking for pairs of numbers. We got a pair of 2's and another pair of 2's. So both of those are going to come out. So we've got what out front of the root here?
4 plus or minus 4 to the power of 11.
Okay, radical 11. Yep. And then negative 16. Now, this isn't a perfect answer because we have these right here that all have a common factor. What could we divide all of those by? 4. So let's do that. If we divide them by 4, what is it going to look like? Negative 1 1 root 11, or just root 11, over negative 4. Okay? When you have a radical in your answer, you don't need to write them separately. I know that there's 2 answers here because of the plus or minus. Okay, so we're still going to use this simplifying radical stuff that we talked about earlier. Questions before we try one more? Okay, this one also needs to be updated a little bit. Yeah, we got to move that 9 over. Okay, discriminant, b squared minus 4ac. So we've got 2 squared minus 4ac. Is it negative 16? Okay. All right, so let's jump down here quick. We just found out that this number goes right here. What kind of answers are we going to get?
For I,
So we're going to get what kind of answers because of that? imaginary. 2 imaginary answers. Okay, we'll put negative b, 2a. Now somebody said that this over here is 4i. And why is it 4i? I understand the 4, but tell me why it's I. Yeah, anytime you have a negative under a root, remember an I comes out, that imaginary notation. Okay, over 2. But we could simplify this, right? We could divide them all by 2. So what does this become? Negative 1, 2i. Do we have to have something on the bottom? No, you can have a 1 there, but you don't need to write that. Okay, so that would be 2 imaginary answers. Okay, so just as a quick summary, when you have, for this is the discriminant piece of it, if you have a perfect square, like something you can square root like 25 or 36, that's 2 rational roots. A non-perfect square like 15 is 2 irrational roots. A negative number means you have 2 imaginary roots. And if you get 0 under there, let's think about that. So if we had, for instance, negative 7 plus or minus the square root of 0 over 2, what's the square root of 0? 0. So we have negative 7 plus or minus 0 over 2. If we have negative 7 plus 0 and negative 7 minus 0, do we get different answers? No. Okay, so that would only give you one answer if you get a 0 right here. Questions?